Okay, today we're going to be looking at lesson 2.10, day 1, which is on linear inequalities. So if we think about Unit 2 has been all about linear equations. So the new thing today is that instead of having an equal sign, we're going to have one of our inequality symbols. So greater than, less than, greater than or equal to, or less than or equal to. So the general principles for how we graph are going to stay pretty much the same, but we have to kind of take into consideration what it really means to be an inequality. Okay, so for our first problem, we're graphing y is greater than 2x minus 4. So I'm going to just kind of pretend that that greater than symbol is actually an equal to in order to graph. And if that's the case, then it is already in slope-intercept form, which is always good. And so I'm going to identify my slope and my y-intercept. So I know that my slope is going to be that 2, and my y-intercept, that b, is going to be negative 4. Okay. All right, so I'm going to go start plotting my points. I know that negative 4 is my y-intercept, and then I'm going to be going up 2 over 1. I'm going to keep that up. Now, before I connect my points with a line, oops, I made a little mistake there. Before I connect my points with a line, I do want to consider I've got a greater than symbol. Okay, it is not a greater than or equal to. If we think back to when we did Unit 1, Part 2, which is basic inequalities, right? If we had a greater than symbol or a less than symbol, we would always use an open circle. And that's because anything that was on that circle was not a solution. So similarly with an inequality, a linear inequality, our line is going to look a little bit different. If we have a greater than or a less than without the equal to, then we're going to end up with a dotted line. So I'm going to write myself a little note here that this is going to be a dotted line. Okay. The way that I show that is just trying my best to make it look like it's not solid. Some people like to draw the line and then erase a little piece. If you're ever wondering or worried that I'm not going to know, you can always just draw me a little note and say, like, this is dotted. And the reason that it's dotted, what it really means is that anything that is on that line is not a solution. So remember, when we talk about linear equations, anything that's on the line is a solution. But when we're talking inequalities, that's not necessarily going to be the case. If I were to pick any point on this line, I'm going to look at 5, 6. And if I try plugging it into my original inequality, so this is 5, 6, we'll see how it's actually not a solution. So if I plug in my values, it's going to give me this, and I'm eventually going to get 6 is greater than 10 minus 4. And so 6 is greater than 6, which is not true, right? So 6 is not greater than 6. However, if it was 6 is greater than or equal to 6, then it would be a solution. And so we would draw a solid line. Okay, so we are not actually done right now because technically we haven't actually graphed any of our solutions. We have our line there, but none of the points on the line are solutions. So we need to figure out what to do from here. If we think back to basic inequalities, right, we had to do some shading. So we're going to have to do some shading here as well. But it's going to look a little bit different than just with one variable. Okay, so if I look here, I've got two sides to my line, right? I can go to the left or I can go to the right. I'm going to be shading one of those, and I just don't know which one yet. Remember, whatever I do shade, it means that that's a solution to our inequality. So we can test any point that we'd like to see if it satisfies our inequality. The easiest point, and the one that I always recommend, as long as it's not on the line, is 0, 0. So I'm going to test the point 0, 0. And what I mean by that is I'm going to go back to my original inequality, and I'm going to substitute in 0 for y and 0 for x, and I'm going to see if I get a true inequality or a true statement or not. Okay, so I'm going to plug in. You guys can do the same. Okay, and this is going to give me 0 is greater than negative 4. If I think about that, yep, 0 is greater than negative 4. Okay, so if it is greater than negative 4, then that means that 0, 0 is a solution. So this point right here is a solution. So if that's a solution, then everything on this side of the line is also going to be a solution. Okay, so I'm going to shade it all in, obviously stopping at the line. Okay, I don't want to go over that line. Anything that's in this region is a solution. So for instance, if someone asks you, oh, is negative 5, 5 a solution? You would look at your graph, negative 5, 5 is here. It's in the shaded region. So yes, it is a solution. If someone said, how about for negative 5? That's down here. it would not be a solution. And that would be true also if you went to go plug it into your inequality, you would not get a true statement, okay? So if 0, 0 is a solution, just a general rule is that we shade where 0, 0 is. Shade the side with 0, 0. Okay. And if it's not a solution, we would shade the opposite side. But in this case, it was a solution. And so our inequality is graphed. Okay. Let's take a look at our next problem. I bet you guys could probably pause and try this yourself. But if you want to just keep going, I'm going to keep showing this as well. So this one again is in slope-intercept form, which is nice. This time we have a less than or equal to symbol, so we will end up with a solid line this time. Think about when you had inequalities, we had a closed circle. It's the same as this solid line, okay? And it looks like I have my important information here. My slope is negative 2/3. My y-intercept, or b, is negative 2. And I'm going to go graph my points. Okay, so I've got negative 2, and then I'm going down to right 3. Okay, I want to make sure all of our points are there. Perfect. Okay, but since this is a less than or equal to sign, then that means anything on the line is a solution. And so I do want to graph a solid line this time. So I'm going to graph my solid line. Okay, we still are not done, right? We know that anything on the line is a solution, but there's also going to be more than just that, right? Because it says that y is less than or equal to. It's not just the line itself. That would be if it was only an equal to. Okay, so again, we can test any point. But again, I always like to test 0, 0 because it is the easiest point to plug in. So I'm going to try plugging in 0, 0 again. Okay, so that's going to be 0 is less than or equal to negative 2/3 times 0 minus 2. That's going to give us 0 is less than or equal to negative 2, which is not true, right? Negative 2 is actually less than 0. So this is a no, right? So this is a false statement. If it is a no, then we want to shade the side that does not have 0, 0. So shade the side without 0, 0. So if I look at that, that is going to be the side right here that I'm going to shade, okay? Anything in this shaded region, and obviously as it extends, if we were to see a larger portion of the graph, anything in this area is a solution to our inequality, okay? And then anything outside of it is not, okay? And you can always test other points if you want, but if you do the test and it proves, then you should be good with just the one point, okay? So that is that one. Let's try our next problem here. So if you look at this one, the only difference that I can see for sure is that it's not in slope-intercept form. Okay, so why don't you take a moment to try to get it into slope-intercept form, okay? You can pause if you'd like, and then come back and see if you agree with me. For those of you that are still with me, I am going to get this into slope-intercept form. So I'm going to subtract my 6 from both sides, and that's going to give me 2y equals 4x, not equals, sorry. Oops. Greater than 4x minus 6. Okay, divide everything by 2, and I'm going to get y is greater than 2x minus 3. Okay, now that it's in slope-intercept form, I'm going to graph it just like usual, starting at negative 3 and going up 2 over 1. Let's keep it up. This time I do have just a greater than symbol, so it is going to be a dotted line this time around. I'm going to use my fancy tool here to do that, but you guys can make sure you draw that in. If this was a quiz or a test, you would get a point for drawing the right type of line, a point for the right shading, a point for showing your work, and so on. Okay, so I'm not done yet, however, right? I need to still test my point. I am going to test 0, 0 again since it is not on the line, okay? And we'll see what we get from there. Okay, so I'm going to plug in 0, 0, So that'll be, oh, this is important. You always want to make sure that you go back to your original inequality, not the simplified version that I have right here, y is greater than 2x minus 3. Because if I potentially made a mistake in getting it into slope-intercept form, then I'm also going to make a mistake with my shading. So I'm going to always go back to the original. Okay, so that means I'm going to plug it into the 6 plus 2y is greater than 4x. So I'm going to do 6 plus 2 times 0 is greater than 4 times 0. We're going to get 6 is greater than 0. And that is a yes, that's true. Okay, so that means we're going to shade the side that has 0, 0. The side that has 0, 0 is to the left of our line. And so I'm going to shade that area like so. This bottom section here, we're actually going to fill that out on Monday together, just kind of summarizing what you guys learned in this lesson. We'll talk about the line styles, the shading, and the solutions, and we'll have a day 2 on this on Monday. Okay, so why don't you guys give the class kick a try. Make sure if you finished early, you've got Delta Math or an early finisher activity. Also, today is the last day for any late assignments, so make sure you finish those up. So that I can get them into the grade book for your trimester 1 grades. All right, have a great weekend.